Everybody knows that the engine in their equipment requires oil in the crankcase to lubricate the many moving parts and wearing surfaces. It is inconceivable that we would intentionally run our equipment without the proper lubricant in the crankcase. Oil is necessary to keep piston rings, bearings, cams, in fact, the whole engine running smoothly. You are probably unaware that one system in your engine may not be receiving adequate lubrication. Without this system, the engine won't run, and repairs due to wear or failure can be costly. They're not even covered by most vehicle warranties. We're talking about your fuel system, from the pump to the injectors and especially the fire side of the combustion chamber. Today's engines run faster, hotter, and have closer tolerances than ever before. Fuel pumps, fuel injectors, compression piston rings, and valves are subjected to higher loads and more severe temperatures and stresses. In addition, new diesel fuels are being more severely refined, creating drier fuels with reduced lubricity. The need for top-end lubrication has become critical.
New fuels are being hydrotreated to remove sulfur and aromatic compounds that produce harmful emissions, but helped to lubricate fuel systems. The severe refining will have a dramatic effect on fuel system component wear and premature failures. Reduced aromatic content has resulted in large numbers of fuel system leaks caused by O-ring and seal failures. The reduced aromatic content will also have a negative impact in winter operation because increased levels of waxing may result. A recent study by the Stanadyne Group, who manufactures precision fuel injection pumps and other components for diesel engine manufacturers, concluded that 1. Hydrotreated low-sulfur fuel has lower lubricity than traditional fuel, and 2. Low-sulfur fuel can cause accelerated wear in precision fuel injection systems. This is a disassembled distributor fuel pump manufactured by Stanadyne. Note that the precision surfaces of the timing ring, the rotor, and the vane pump parts are subject to wear and premature failure when fuel of low lubricity is used. These pumps are used on many automotive, agricultural, and industrial engines. John Deere has also reported problems with poor fuel lubricity causing premature distributor pump wear or failure, engine speed instability, injector nozzle plugging, hard starting, low power, underrun, and engine smoke. John Deere concluded that the cause of these complaints is reduced diesel fuel lubricity resulting from the reduction of sulfur content caused by hydrotreating. Cummins Engine Company has also reported some additional problems, such as reduced injector plunger durability, O-ring failure, and the seal failure on the throttle shaft of the PT fuel pumps. Also, the PT fuel pump governor plunger is susceptible to increased wear. Cummins, John Deere, Stanadyne, and Bosch are all recommending the use of diesel fuel additives to improve lubrication quality, impart oxidation stability, and provide corrosion and deposit protection. These manufacturers, particularly John Deere, caution users that many diesel fuel additives are designed to improve the cold weather flow and stabilize the fuel only. Many are alcohol-based and do not improve the fuel's lubricity. In fact, some alcohols do not even mix with diesel fuel.
Power Up Lubricants of Calgary, Canada, a manufacturer of high-quality specialty lubricants, has developed one diesel fuel additive which is both alcohol and sulfur-free. Power Up Gen49D. Named for its original use in diesel generator sets in the 49th state, Alaska, it has proven its value as a fuel system lubricant. Gen49D begins working in the pre-flame zone of the fuel system by preventing corrosion of the fuel tank and helping stabilize the fuel. After passing through the fuel filter, the fuel enters the fuel pump. The only lubricant of the fuel pump is the fuel itself. Particularly in rotary or distributor-type fuel pumps, excessive wear and premature failure can result if the fuel lacks adequate lubricity. Better fuel pump and injector lubrication generates a better fuel mist, improving the combustion efficiency. The pre-flame region before the fuel enters the combustion chamber is only a small part of the complete protection offered by Power Up Gen49D. Gen49D is designed and formulated to lubricate the top end of the combustion chamber where the severe stresses of burning new dry fuels causes premature wear and poor performance. Gen49D's combustion products are high load carrying, boundary lubricants that lubricate the compression piston rings and the exhaust valves. The protective lubricating film is continually burned off and replenished during operation. Gen49D provides complete fuel system lubrication and protection to improve engine performance and equipment life. Power-Up Gen49D customers have claimed ease in starting, increased horsepower, reduced fuel consumption, no hesitation, and less engine smoke as some of the benefits of using Gen49D. According to independent third-party tests, including fuel lubricity and comprehensive diesel engine vibration analysis, Gen49D greatly improves equipment performance. These vibration signatures from a stationary Caterpillar engine show the difference in vibration before and after applying Gen49D to the fuel supply. In these charts for cylinder number 5 and cylinder number 7, it is obvious that there is a significant reduction in the vibration amplitudes. This is a direct result of improved lubrication of the fire side of the engine. The increase in vibration just before the 720-degree crank angle corresponds to the point where fuel is injected into the cylinder. The significant increase means that the fuel pump and injectors are more efficiently introducing fuel to the cylinder. Wear scars were generated during a ball-on-cylinder lubricity evaluation, or Bockel test. The Bockel test is an ASTM standard method to evaluate the lubricity of fuels. The test consists of a hardened steel ball wearing against a rotating steel bearing race. Poor diesel fuel lubricity will result in increased wear on the steel ball. The photograph is a magnified picture of the wear scar left when diesel fuel only lubricated the interface. The average wear scar diameter is 0.63 millimeters. This photograph shows the wear spot left on the ball bearing when 0.1% Gen49D is added to the same fuel. The fuel's lubricity is improved dramatically. The wear spot diameter is only 0.36 millimeters. The scar is over 3 times smaller than without Gen49D. It is also obvious that there is significantly less scoring of the worn area. Power-Up Gen49D provides superior fuel system lubrication from fuel tank corrosion inhibition to the fuel pump and injector lubrication, and most importantly in the combustion chamber itself. Gen49D is not alcohol-based, does not contain sulfur, and does not affect the physical properties of diesel fuels including cetane index, carbon residue, and pour point. Use Gen49D fuel system lubricant in your diesel engines. You will be rewarded with long and efficient diesel engine operation, reduced overall maintenance costs, and a dramatic reduction in fuel system problems, providing both reliability and dependability. Talk to your Power-Up distributor today or call 1-800-661-7777 and ask for information about Gen49D diesel fuel system lubricant and the full line of advanced lubrication solutions available from Power-Up. You'll be glad you did.